All right, here we are back again. We're going to do part 2 now, where we're trying to prove that vertical angles are congruent. So we've used this angle relationship before, but we haven't actually established why they're congruent. And so we're going to go ahead and do that now. And as I said, this is the start of getting into some more formal proofs. So watch carefully. Make sure you're taking good notes here. All right, so the theorem says that vertical angles are congruent. And we're given that angle 1 and angle 2 are vertical angles. We have a picture, okay? And we're proving that angle 1 is congruent to angle 2. So again, with all proofs, always start with what's given to you. So for number 1, we're going to start with that angle 1 and angle 2 are vertical angles. Now, for angles, I'm just going to use the angle symbol because mathematicians are lazy. And we're given that information. Okay, it's either in front of our face with the picture or written out here. So number 2 then is we're trying to get from that they are vertical to that they are congruent. And we actually can't just say, because you told us that they're congruent. We have to prove it. But one thing we can use is the idea of supplementary angles. Angles that lie in the same line add up to 180 degrees. So if I look over here at angle 1, since that's one of the ones I want to be working with, angle 1 lies on the same line as angle 3. Do you see that? It's this line here, and angle 1 and angle 3 would form 180 degrees because they are a linear pair together. So what I'm going to say now is that the measure of angle 1 plus the measure of angle 3 equals 180 because they are supplementary angles. Okay? You don't want to be using the angle relationships with these proofs because we haven't necessarily proven them. As we were trying to prove vertical angles are congruent, I wouldn't want to use something like linear pairs, okay? But we are saying that they are supplementary angles. And in our third step, if I can say that these two are supplementary, and I also want to include angle 2 somehow in all of this, if I look at angle 2, that lies on the same line as 3. And I would rather use this angle versus this line with angle 4 because I've already used angle 3. I want to build a relationship to get from here to here. So I'm going to focus on the fact that angle 2 and angle 3 also lie on the same line. So I'm going to say now the measure of angle 3 plus the measure of angle 2 is equal to 180. And I can use the same reason I already used. I'm going to say supplementary angles. Alrighty then. So I know now that I have the measure of angle 1 and 3 add up to 180. Measure of 3 and 2 add up to 180. And so I get to use now my favorite theorem or favorite property of all, where if I have this equals that and that equals that thing over there, then this and that thing over there must also be equal. So we're going to say, since measure of angle 1 and measure of angle 3 equal 180, measure of angle 1 plus the measure of angle 3, since they're at 180, and the measure of 3 and 2 are 180, they both have to be the same thing. They equal each other. And if you recall, that's my favorite property, which is called the transitive property of equality. Okay, so building from that then, okay, if these two things equal each other, I can do a little bit of math here. What happens if I take away the measure of angle 3? Whatever I do to one side, I do to the other. And if I do that, I'm left with just the measure of angle 1 is equal to the measure of angle 2. And the reason for that is because of the subtraction property of equality, because that's what I did. I subtracted. Okay. Now this is why I number my my reasons and statements, because sometimes, like I said, you end up using 2 lines, especially if you like to write big like I do. So I'm just going to do reason number 6 down below here, okay, and just maybe extend this line a little bit. You might not need to. Maybe you were able to squeeze it all in one line. And since I know that the measure of angle 1 and the measure of angle 2 are equal, by definition, they must be congruent, because congruent lines, or congruent angles, have to have the same measure. So I am able to say now what I wanted to say all along, that angle 1 is actually congruent to angle 2 because their measures are the same. So our reason for that, you can put 6 up there or down here, it doesn't matter. You can put it here or here. Number 6 is because that is the definition of congruence. I'm just going to use a little congruency symbol there. So there's our proof for why vertical angles are congruent. Okay, then we have a reason why we're allowed to say that they are the same. Okay, so that's useful. Now that I've proven that vertical angles are congruent, I can use this idea all the time. It's been proven. Proven. Little exclamation point there. And a happy face. Okay, so that makes us very happy, because now in other proofs I can use the idea that vertical angles are congruent because I already showed people how it's done. So let's take a look at our next proof. Okay, they give us a new postulate where it says that corresponding angles postulate. If a transversal intersects 2 parallel lines, then corresponding angles are congruent. So in other words, angle 1 is going to be congruent to angle 2 because they're corresponding. Okay, this is something that we're going to take for granted. We do not have to prove it because it's a postulate. So postulates are corresponding angles, theorems are vertical angles, and all the other angle relationships that we've talked about before but haven't actually proven. But don't forget, we just proved that guy, so we can use it. Okay, so taking a look, we want to prove the interior angle theorem. I want to prove that alternate interior angles are congruent. And I'm given that A is parallel to B. So these lines are parallel. Don't forget, that's what those little pink triangles mean. And I'm proving that angle 1 is congruent to angle 3. So these guys, these alternate interior angles. Okay, so I'm going to expand this out a little bit because, like I said, I like to write big. They've already numbered our statements and reasons, so we know that we should have 4 statements and 4 reasons. So let's take a look and see what we can build here. Start with what you know. Okay, we have been told that A is parallel to B, so let's do that. A is parallel to B because it's given. Okay, and I'm going to go start building from here. Now, because they just gave us a postulate right before we did this example, we're probably going to end up using it. And in fact, if I look at my picture here, I know I'm trying to prove angle 1 is congruent to angle 3. So I'm going to go ahead and look here at either angle 1 or 3 and see if there's something else I can use. See this angle 4? That guy is corresponding to angle 1. So based on the postulate we just talked about, I can say that angle 1 is congruent to angle 4 because they are corresponding angles. That's the corresponding angles postulate. And again, I'm going to use POST for postulate. Boom. So it's the corresponding angles postulate. All right. So we have that angle 1 is congruent to angle 4. What else do we know here? Well, if I look at where I've gone with this, I said 1 to 4. 4 is actually vertical to 3 because it runs right across from it. So we've already proven that the vertical angles are congruent. So I can say angle 4 is congruent to angle 3 because of the vertical angles theorem. I can't say postulate because we proved it. It's a theorem, but I'm going to say because of the vertical angles theorem. Okay. And then last but not least, again, it's my favorite. Angle 1 congruent to angle 4. 4 is congruent to 3. So this congruent to that congruent to that thing over there. This must be congruent to that thing over there. So angle 1 is congruent to angle 3 because of the transitive property. And I got to use congruency here. Transitive property of congruence. Ta-da! I love it when we prove stuff. It's so nice because it's really important to understand where all this stuff is coming from, how it came to be, and that way we are able to use it without any fear of being wrong. So I'm going to go ahead and check off this guy from my list. And I'm just about out of time for this video as well, so I'm going to stop here. There will be a part 3, so stay tuned.